Okay, let's go. All right, so first and foremost here, we're on section 4.4. We're doing the trig functions. It's the last day of it. The big thing here today is I want to review homework problems. So this is kind of the thing I want to do today. We have a couple different problems I want to cover. I want to do 2 problems that are on coordinate planes. So we're going to do 2 of these. So we're going to do 2 of them. Okay. Each one will require that you know the positive and negative sign chart, which I'll have on the board. It'll be a little small. You already should have it in your notes. Now, if you haven't received a property sheet, I don't know, I think everyone has. If you have not received a property sheet from me, I have one left. I think this is the one that I should have left because I think everyone should have one as of this moment. Question?
I need that.
You already got one yesterday.
Yeah, but I don't want that.
I'm not giving you this one. I need it. Okay. All right. Special triangles. You need to have that written on your property sheet as well. Now, the other problem that we're going to do one of these. We're going to evaluate trig functions. That'll be one that we're going to do. This one will require on this evaluation that you know how to do reference angles, you know how to do coterminal angles, all that good stuff. Okay. Now, homework today, due Wednesday. Okay, the homework that I assigned today. Over the weekend, I'll update grades and stuff, and I'll hand back some papers Monday so you can kind of see what you have. The reason why we're kind of rapidly approaching the end of the chapter, we only have a couple sections left. I think we have 2 sections left. So I'm expecting a test not next week, but the week after at some point. So by maybe as early as Thursday or Friday next week, we could potentially be starting a review. But I'm not expecting a test next week. It'll be the week after. Okay, questions on kind of what we're doing today? All right, let's jump to it. Okay. Hey, try to keep talking down to a minimum. All right, so this is our first one. If you read the instructions here, I try to include the instructions from what our book has. It says the point on the terminal side of angle x. Instead of using theta, I put x. I couldn't get theta to show up correctly. Find the value of each trig function, and this is what they give me. They give me a coordinate. This is what your book will do on the first couple problems. I think you have 2 of these. So, all right. So, we have to find the trig functions for this. The first thing you have to do, you would have to draw a mock picture of where that thing's at. It does not have to be exact. Okay? So, 3, -5. So, it's 3 over, -5 down. This is where we're going to be. So, 3, -5. That's the right triangle here. So, if I draw this out, I'm going to draw this triangle. Here you go. Okay, so here's my right triangle. The angle x is right here, and we're going to fill in the numbers where they need to go. So I went 3 over. So this wall right here is 3. The wall going down was -5. Now that I have that, we can do Pythagorean theorem and figure out that part. So again, if you can't see the triangle, this is what I'm dealing with. That it's a right triangle. It's 3 here, -5 going down. This is my angle x or theta or whatever variable you want to call it. We have to do Pythagorean theorem to figure out this missing wall. That's the first step when you start these. You're going to have 2 of these again. But again, let's do the Pythagorean theorem here and actually solve. So we have 3 squared plus -5 squared. And again, why I'm adding those 2 and squaring them. On the Pythagorean theorem, these are the legs. So you have to make sure that you're squaring the legs and adding them together. I don't care if one of the legs is missing on whatever problem you're doing, but that's how you set the Pythagorean theorem. The question mark, I'll call it C. That's c squared. So this is 9 plus 25 equals c squared. To solve for c, you take the square root of this number, which is 34. Now, you can leave that. You do not need to break those down. I know that square root of 34 is not a pretty number.
It's like 5.830.
Okay. Leave it a square root. You don't even need to go to simplest radical form. So the hypotenuse here is the square root of 34. And that would be, by erase a part here. Let's see. I can get rid of this part, and I can put in that square root of 34 right. Seriously, pick. All right. I can put this right here. Okay, so now we're going to do the 6 trig functions from that triangle. So when you set this up, and I have these all entered. Okay, hey, does everyone have this all written down though?
Yeah.
Okay, now if I set this up, I'm going to be finding the sine of x, the cosine of x, and the tangent of x. Shh. Hey, I'm going to remind people again. Okay, then I have cosecant, secant, and cotangent. It really comes down to, like, you need to get the first three, the main three trig functions. Okay, for sine, it's the opposite over hypotenuse. Well, for x, if x is right here, if x is right there, that means that the opposite wall would be the negative 5, the hypotenuse is that root 34. Okay, freeze. Shh. Done. Okay. Then to flip that over, I have root 34 over negative 5. Okay, so that's the first ones. Now cosine, if I do cosine now, let's go to a different color here. Let's go to maybe blue. Now I have to do the adjacent wall. The adjacent wall to x is the 3 over square root of 34. And then flip that over, that's root 34 over the 3. And then for tangent, I'll pick another color again. No, I'm not going to pick yellow. Tangent would be the opposite over adjacent, and then flip that over. Now, again, that's where x is sitting. X should always touch the origin. That's how I know. It should always be there. It should be touching the origin, or theta, whatever angle you want to call it. Now, 4 of these trig functions should be negative if you're not in the first quadrant. The first quadrant, if you're looking at this, the first quadrant, all trig functions are positive. So the idea here is that no matter what you have, the trig functions have to be positive in the first, so all 6 of them. We were in the 4th quadrant, so that told me that sine and secant were positive, and that's what we have. As you can tell from these 2, they were positive, the other ones were negative. That's something you should check in the end. Questions, comments about this first problem? Perfect, let's move on. Okay, second one, very, very similar to the last one. The only problem is you're not drawing the coordinate right away. You don't have, a coordinate you can go on the x-axis. You have to use the 2 clues that I'm providing you to kind of figure it out. Okay, so this one, if you're looking at this is positive. So the sine of x is a positive number. It's positive 5 over 13. The cosine is negative. So that means I'm not in the first quadrant automatically because one of them is less than 0. And to figure out where I'm at, sine was positive, so I was either here, and we already eliminated that I wasn't in the first. The reason why I'm not in the first, that one was negative.
You can't be in number 4.
So, and you're not in 4 because that's where cosine would be positive. So, and sine wouldn't be positive in the third. So you have to throw that one out. So I am in the second quadrant. Now I can draw my triangle. When you draw the triangle, you don't even have to be accurate. Just draw a triangle. We know we're in the third. You can put whatever letter you want. If you want to put theta, if you want to put beta or alpha or x, maybe you want to put that as your angle. That's fine. But I'm using x, so I probably should have put x here. So that's my angle. The sine, which is 5 over 13, that's opposite over hypotenuse. The opposite of x is the 5. The hypotenuse is the 13. Now, if there's any negatives, the hypotenuse can never be negative. So figure out where the negative sign would go, if you have it. Now, doing Pythagorean theorem here, this is the wall that I'm missing. So 5 squared plus whatever that question mark squared is equals 13 squared. So this is 25 plus the question mark squared equals 169. You subtract that over, you get 144, and you're absolutely right. The question mark is 12. So this length here is 12. Now, yeah, that was the other thing I was going to tell you. That I think I deleted a wall. I didn't. All right. But anyways, putting the 12 there, putting the 12 here, you have to make sure it's negative because you're in that second quadrant. The negative numbers go this direction and down. So I do have a negative 12 there. Now I can set up all my trig functions. Okay, so if I get rid of this, we know that that wall was 12 because of the Pythagorean theorem. So now I can set up my trig functions. So you should not get sine wrong. Sine of x, that's the 5 over 13. You shouldn't get its reciprocal wrong. Cosecant, that's 13 over 5. The other trig functions are cosine, secant, that's its reciprocal, tangent, and cotangent. Now, cosine for this is the adjacent wall to x. This is the adjacent wall That's the wall right next to x. So that's negative 12 over its hypotenuse, which is 13. We flip that over. That's 13 over negative 12. And again, I don't care where the negative sign goes. Moving on for tangent, that's opposite. This is the opposite wall to x. This is the adjacent, so it's 5 over negative 12. And you would flip that over. Okay? All right, questions on how to set up the 6. Now, it says in the instructions you have to find the 5 remaining ones, the remaining trig functions. I do want you to list all of them. Do you agree that this problem is very, very similar to the first one we did?
Yes.
Yeah.
Different setup. To know which quadrant you're in, you have to use both clues. The positive and negatives will give you the clues. Okay, we good though?
Yeah.
Moving on. Last problem of the day. Okay, on this one, we're going to be finding reference angles and or coterminal angles and evaluating this trig function. And now if you notice my graph, I will draw this roughly where it's going to be, and then you have to use the special triangles to do this. Okay, not just Pythagorean theorem. You have to use the special triangles because usually the angle I give you will be one of the specials. So on this one, secant, basically this is the reciprocal. This is the reciprocal of cosine. So the idea here is I'm going to actually find cosine first, and then I'll just flip the answer over. Now 240. 240, if it's not really hard to figure that one out, you're in the third quadrant. You're down here. So I can already tell you right now, this answer is negative. It's a negative. Because I'm in that third quadrant, cosine's negative there. Because if you look back at the last slide and I looked at the positive and negative sign chart, you're in the third quadrant, tangent, cotangent are positive here. Secant and cosecant are not. Sine and cosine are not.
You had that memorized.
Okay, so at this point, if I'm in the third quadrant, let me get rid of these markers that I have on the actual drawing, so I know I'm in this quadrant. So if I draw the triangle here, I bring it back to the x-axis. This was 240 degrees. I have to subtract it from 180 because that's the marker. That's your y. That's your x-axis on that side. So if I subtract, I get 60-degree angle. So now I know it's got to be this triangle. It's got to be that special triangle of 30, 60, 90. The side opposite of 60 is root 3. The side opposite of 30, this is a 30-degree angle, is 1. The side opposite of 90 is 2. So if I erase some of these parts here, I don't need the 240, I don't need the 180 anymore. And now 2 of these angles are negative. The 2 angles that are negative, or the 2 walls that are negative, I should say, are these 2. So negative 1 and negative root 3, because that's going left and down. And now I can set up my trig function, and again, the angle I'm using is this one. That's the reference angle. It's the angle right next to the origin. So if I set up cosine, cosine is the adjacent wall over hypotenuse. Adjacent over hype. The adjacent wall is negative 1, and the hypotenuse is 2. Well, I don't want cosine. I wanted secant. So what I have to do is just flip that answer over. So I'm going to do the reciprocal of this. So I know that, if the cosine's answer, if cosine of x, or of 60, I should say, not x, but 60 here, cosine of 60 is negative 1/2. I flip that answer over, so it's negative 2 over 1. And I don't care where the negative sign goes. That's the answer I'm looking for. That's the exact answer for this. We evaluated all the way. Okay, questions, comments about that problem? Now, you do not have to simplify the fractions down. It will always use one of the special triangles. That's why I've been giving them to you. But that's what you're going to do. I think you have 4 of these, because 2 of them will be degrees, like that. 2 of them will be in radians. You would have to convert them.
Oh, okay.
And they'll be definitely, one of them will be definitely past 360. So you have to bring it back to see where it's at. Okay, I think a couple of the angles might be negatives, some will be positive. So you're going to have a couple, you have more of these, because I feel that these are probably the most relevant to us. The other ones are kind of like way too much work, so you will have less of the other 2 that we did. All right, here's your homework today. It's due Wednesday, February 7th.
February.
You have 8 problems there. 3 and 8, those are the ones where they give you the coordinates. You have to draw them, rough scale drawing, find all 6 trig functions. Again, your angle is always at the origin. 24 and 26, that's where you have to use the clues, figure out which quadrant you're in, the 2 clues they give you. Draw them, find all the 6 trig functions, actually the 5 remaining ones. And then the last 3, I guess, or last 4, I should say, the last 4, those are the ones that you're actually evaluating the trig function. They just give you one angle, and you're just going to go find it. It will be a special triangle of some sort. Now, if it's lands right on a quadrant, let's say it's like 180
Zero
or
and one.
270,
Use that sign.
zeros and ones, that's what we're going to be looking at. I will probably go over an example of that Monday if you have one. I think the ones I picked you shouldn't, but if it did, like let's say I just got unlucky and I didn't see it, if you do land on one of the quadrants with one of those 62 through 82, those, I will talk about on Monday. Okay, so I might even give you that one for free. Okay, so, but take your time, especially on those first four. There's a lot of points on those. Don't just skip over those, especially with negative signs. Okay, there's your homework. We're done for the day. If you have any questions, you want to see some, I'll go through those here in a minute with you personally. But I think those are pretty straightforward. We've done a lot of notes this week. Take your time on this. Okay, there you go.
That's your question. Which one of these combinations?